Good morning and welcome back. Hopefully over the weekend or last Friday, you took your Chapter 7 test. Okay, if you didn't, make sure you get that done sometime pretty soon. So go into It's Learning and do that. Today we are going to start Chapter 8. The first part of Chapter 8 deals with the Pythagorean Theorem, which maybe you don't quite remember what that is, but I'm guessing if I write this out, you'll have a clue. So remember, it's a squared plus b squared equals c squared. Okay, where c is our longest side, c is our hypotenuse when it's a right triangle. Okay, so right here it says verify that this is a right triangle. So we're checking if there's a 5 and an 8 and a 12. First off, you know the 12 has to be your c. So we're checking, will this satisfy the Pythagorean theorem? So is 5 squared plus 8 squared. I'm going to put equal with a question mark. Is it equal to 12 squared? So we'll check. So 5 squared we know is 25. 8 squared is 64. If you're not able to do that in your head, that's fine. Just use a calculator. Okay. Remember, 8 squared means 8 times 8. So 12 squared is 144. And we add 25 plus 64. That's going to be 89, which 89 is not equal to 144. Okay, so this would not be a right triangle, so the answer is no or nope. Okay, now our next one. This one might give some of you guys some anxiety because you see this 8 squared root of 6, this 8 squared root of 15. It's okay. We do the same exact approach. Now, it's not going to be as easy to write out, but 8 squared root of 6, if we square that, we can square that, and remember, we said 5 squared is the same as 5 times 5. So 8 square root of 6 times 8 square root of 6 is the same as 8 square root of 6 squared. Now, to do this, we do 8 times 8, which is 64, times, remember, square root of 6 times square root of 6 is going to give us 6. Now, 64 times 6, that gives us 384. Okay, now we're going to add that with 24 squared, which gives us 576. If we add those two together, we would get 960. So that's for the a and the b squared. Okay, a squared and b squared. Now we have to check out this c squared. So let's see if that one works. So 8 square root of 15 times 8 square root of 15. In that case, 8 times 8 is 64, times square root of 15 times square root of 15 is 15. And that will be equal to 960. Those are the same, so the answer is yes, it is a right triangle. I could go ahead and put that there. Okay, so now, at the bottom here, still using the Pythagorean theorem, instead of verifying these things, we're just finding the missing side. So here the missing side is x. So x is our c. It's across from the right triangle there. So we're going to do 8 squared plus 15 squared equals x squared. 8 squared is 64. 15 squared is 225. That's going to equal x squared. We add them up. 289 equals x squared. Now to get rid of that square, we got to take the square root. So we do that to both sides. Square root of 289, you might not know this, but it's 17. Okay. Now, up here it said, is it a Pythagorean triple? And in our case, a Pythagorean triple, that just means all three sides are whole numbers. All three sides are nice whole numbers. There's no, like up here, this was not because there was a square root. So 8, 15, and 17, that is a Pythagorean triple. So we could say yes. Now your next one. Here we want to do it again. So 8 squared plus 12 squared. It's still the c that we're looking for, equals x squared. So 64 plus 144 equals x squared. 208 equals x squared. We take the square root of both of those. Now, the square root of 208. This is not a perfect square, okay? And the way we can check that, I know you guys, some of you have this calculator, some of you don't, but if you take the square root, so second over here, square root of 208, and I hit enter, you see that doesn't come out to a whole number, okay? So it's not a perfect square. So instead, to figure out what this is, we can break it apart. So think of what are some multiples of 208. So 4 times 52 would work. If you couldn't come up with that, 2 goes into it because it's an even number. So start there. Now 4 breaks apart to 2 times 2. 52 would be, 2 times 26. Okay, the 2's stay. 26 would be 2 times 13. And at this point, we are done breaking it apart. Now, remember a square root? We circle our pairs, and that's going to come out front. So 2 comes out front. We have a second set of 2's. That'll also come out front. This 13 has no partner, so that stays inside. 2 times 2 gives us 4. Square root of 13 is our answer. Now, since that is not a whole number, it's not an integer, we're not going to have a Pythagorean triple. Okay, down here we do the same thing, okay, except this time we are already given c. 24 is our c, so a squared plus 22 squared equals 24 squared. So a squared will stay here. 22 squared is 484. Once again, I don't expect you guys to know this. Just go to your calculator. And if we do 22 times 22, get 484. And if you don't have a calculator, just go to Google, type 22 times 22. It'll tell you. Use your phone, whatever you need to. 24 times 24 now. And we get 576. So now from here, we subtract 484. Subtract 484. And we're left with a squared equals 92. Okay. Now, from here, we're taking square root again. So let me get rid of that. Square root of 92 does not come out evenly. Okay, so we need to break that apart. And if you can't come up with anything, just do 2, right? 2 times 46. Now the 2 comes down. The 46 would be 2 times 23. We have 2 2's here, so that's one pair of 2's. 23 can't break anymore, so 2 square root of 23. And that is our answer. So once again, when we have a square root, it's not a Pythagorean triple. Okay. Now, this final one you could do again. I'm going to move on just for sake of time, but a squared plus b squared equals c squared. The c is our 18. Okay, now the second thing I want to talk about today. We know the Pythagorean theorem, and when, right here, the converse, and you don't need to write these down, but the converse tells us that a squared plus b squared equals c squared. If that's true, then you automatically know you have a right triangle here. Okay, likewise, it says here if it's greater, if the longest side is greater, so what we mean by that, if a squared plus b squared is less than c squared, meaning the longest side, whatever your c is the longest side. If that's bigger, then it's obtuse. And if it's smaller, then it's acute. So, down here at the bottom, it says, can the numbers represent the side lengths of a triangle? To check that, you always take the two smallest, okay? So 16 and 30, and we add them together. And they have to be bigger than 34. So 16 plus 30 is 46. That is bigger than 34, so we're good. Now, the reason that is the case is if they were not bigger, for example, on this next one, 8 plus 13, that gives 21, so that's not possible. The reason it doesn't work, if you think about it, if I have a side of length 8, another one of length 13, and I put those next to each other, that's only 21 in length, where the third side is 22. There's no way to make a triangle with those, okay? Because it's a little longer. So in our case here, it is not possible to be a triangle. But on this one, we got 46, so we know it is a triangle. Now, we always take the two smallest, so let me switch back to a pen. 16 squared plus 30 squared. I'm just going to put a blank here. How does that compare to 34 squared? So 16 squared. I don't expect you to have this memorized, but to save time, I'll just put 256. 30 squared is 900. How does that compare? 34 squared would be 1156. Okay, so now we add those two together. We get 1156 equals 1156. Because of that right there, they are equal, which means what kind of triangle is it? It's a right triangle. Okay, so example C here. 6, 9, and 12. So first, we put the smallest two, we add them together. 6 plus 9, we get 15. That is bigger than 12, so we're good to go. Cannot be equal, it has to be bigger than. Okay. Now, from here, 6 squared plus 9 squared. How does that compare to 12 squared? So 6 squared is 36, 9 squared is 81. How does that compare to 144? We add these together, 36 and 81. We're going to get, let's see, that's 117, which is less than 144. And because of that, if the C, the big side is, the C, the longest side is bigger, you know it is obtuse. So I'd say obtuse. Okay, 2 more and then we're done for the day. So we take the smallest two, so 4 plus 5, we get 9. That is bigger than 8, so we know it's a triangle. So from now, we can do 4 squared plus 5 squared. How does that compare to 8 squared? So 16 plus 25. Once again, how does that compare to 64? 16 and 25, that's going to give me 41. 41 is less than 64. So once again, if C is bigger, it's obtuse. Okay, your final one, 3, 4, and 5. Let's check. 3 plus 4, that is 7. Okay, so we're good. Now we just do 3 squared plus 4 squared. How does that compare to 5 squared? So 9 plus 16. How does that compare to 25? 9 plus 16 is 25. 25 equals 25, which tells us this is a right triangle. Okay, now none of these were acute, but remember, if it was acute, that would mean your left side would be bigger than your c squared. Okay, a squared plus b squared would be bigger than c squared. That would make it acute. And this last one, it doesn't ask us to, but 3, 4, 5, it's a right triangle. That's an example of a Pythagorean triple. So please sign into Delta Math. There is a short assignment for today. If you have any questions, please let me know. Hope you guys have a great day.